Question 20. Simplify m to the power of 3 times m to the power of 4. Don't really need a calculator for this. That means 3m's multiplied together times 4m's multiplied together, which gives us a total of 7m's multiplied together. We end up adding the powers. If we times indices of the same base, in other words, they've both got m's involved, we're going to add the powers here. So we get m to the power of 7, not 12. Simplify 5np cubed cubed. Now, there's lots of rules you can do with this, but the power's not that high here. So what I'm going to do is I'm going to write this out in full. I'm going to say 5np cubed times 5np cubed times 5np cubed. I'm just making it easier to understand now. On my calculator, 5 times 5 times 5 will give me 125. N times n times n, I know is n cubed. And p cubed times p cubed times p cubed, just like this one up here, we add those powers to get p to the power of 9. And that would be your final answer. There's 125, n cubed, p to the power of 9. Part C. This one here, we just take one part at a time. 32 divided by 4. Hopefully you know that, but not worth, again, if you don't, not harm to check that. It gives us 8. Q to the power of 9 divided by q to the power of 3. When we're dividing powers of the same base, we subtract them. So 9 minus 3 is q to the power of 6. R to the power of 4 divided by r. Well, hopefully you've spotted that that's an r that has a power of 1. So that's r to the power of 4 divided by r to the power of 1. Subtract the powers gives us r to the power of 3. And that's the correct answer there. Question 21. Now there is more sort of methodical approach here that you could use product to prime factors for this, but many of you might get confused with what we actually do with that. And if you're confident with that, then use that method. That's fine. But with something like this, there's no harm in just writing a list of the multiples of 40. And remember, multiples is another saying it's times table. So 160, 200, 240, and so on. Okay, we can keep going as long as we need to go. 56, 112. What did we get then? 100. We keep going with this on and on here. You will get 168. Just keep adding your 50, 56, 224, plus 56, 280, and actually I've just noticed there that's 240, isn't it? So the next one's going to be 280 there, and that's the lowest number in both times tables. So we'll stop there. I know the answer now is 280. This second part, you will now find some understanding of this. These are given as product of prime factors. So A, if I write this out in full, we could say that A is equal to 2 cubed, which is 2 times 2 times 2, times 3 times 5. B is 2 times 2, because it's got a power of 2, times 3 times 5 times 5. A little Venn diagram here would help for both of these. So if we use A and B, we're interested, the highest common factor is going to be obtained from us finding what's common here. So if you notice, we've got a 2, so that can go in there. Another 2, that can go in there. Another 2, no, there's not another 2. A 3. And actually, there's a 5. I'm going to struggle to fit that in there, but that 5 should be in there as well. One of those 5s. So those numbers that are shared by both lists, you can see it either in the lists or in the Venn diagram. If we now multiply those together, so we've got a 2 times 2 times 3 times 5. On your calculator again, 2 times 2 would be 4, times 3 is 12, times 5 would give us 60. And that is the highest common factor.